All right, let's go ahead and get started. We want to talk about predicting products of a chemical reaction in this worksheet. We've talked about 5 different chemical reactions: synthesis, decomposition, single replacement, double replacement, and combustion. So remember, in synthesis, we put things together. In decomposition, we tear them apart. In single replacement, we have one thing, one element, for example, and one compound on the left side. On the left side of a double replacement, we're going to have 2 compounds. And combustion, you remember, is going to have a hydrocarbon and oxygen on the left-hand side. So we're going to choose from these types of chemical reactions in naming the chemical reaction, but also determining the product. So let's go ahead and get started. Let's take a look at number 1. We have aluminum oxide, or Al2O3. Now, of the 5 choices, the only one that really makes sense is breaking this apart. You can't put anything together because there's nothing else to put together with it. A single replacement and double replacement both require 2 reactants, and a combustion reaction requires oxygen on the right-hand side. So this would not be anything, it could not be anything other than a decomposition reaction. So decomposition would be our type of reaction. Now let's talk a little bit about what it's going to decompose into. Well, the answer is, if we break aluminum and oxygen apart, aluminum is a metal, and metals are usually by themselves. In other words, it's not going to be Al2 or Al3 or anything else. But oxygen, on the other hand, is a diatomic element. It's one of the Brinkelhoff elements. So it'll be O2. So we have aluminum and oxygen gas, and what balances this is 2 aluminums on the left, 4 aluminums on the left, 4 aluminums on the right, 6 oxygens on the right, on the left, and 6 oxygens on the right. And so that will do it for the first one. Let's take a look at number 2. Here we have iron and sulfur. Now, the most likely candidate for the product is going to be putting them together with iron +2 and sulfur -2. They'll simply cancel each other out. But Fe2S3 is a possibility. It's not as common as FeS because of the fact that +2 iron is more common than +3 iron, but it's a possibility. And that would be a synthesis reaction since we're pushing things together. So synthesis for number 2. Let's look at number 3. Here we have potassium chlorate. It's by itself, so it has to be decomposition. In the presence of heat, it's going to break down into KCl, potassium chloride, and oxygen gas, right? Again, potassium is +1, chlorine is -1, so there's no subscripts here. Oxygen is a diatomic element. We'll balance this with 2, 2, and 3. Let's take a look at number 4. Here we have an element by itself and then a compound. This looks like single replacement. The question is it going to happen? And the answer is yes. Tin is higher on the activity series than is hydrogen. So tin will overtake hydrogen to give us SnCl4. Now notice that tin has a charge of, its most common charge is +4. So Cl was -1, so when we do the switch, we get SnCl4. Hydrogen is a Brinkelhoff element, so on the right-hand side, it's going to be H2. This is going to be balanced by 1, 4, 1, 2, and again, it's a single replacement reaction. Let's look at number 5. Here we have a hydrocarbon on the left-hand side. It does have oxygen, but it is for the most part made of carbon and hydrogen. Then we have oxygen on the left-hand side as well. The combustion reaction has the same products regardless of the hydrocarbon, CO2 and H2O. And so then it just becomes a question of balancing. 1, 3, 2, 3 will balance this reaction. Let's take a look at number 6. Number 6, we have sodium sulfate and barium chloride. So the question is, are we going to get a solid? So if you look at your solubility chart, you're going to find that NaCl is aqueous, but BaSO4 is a solid. I'll put an S right there. So check your solubility chart to ensure that barium sulfate is indeed a solid. And because a solid is produced, we're going to get a reaction. So this is a double replacement reaction, 2 compounds, one here and one here, switching partners to become sodium chloride and barium sulfate. We get a solid, so 1, 1, 2, 1 balances this reaction. Let's look at number 7. Number 7 is potassium fluoride and bromine gas. Notice that bromine is the anion this time. So the question is bromine more active than is fluorine? Will bromine overtake fluorine? Not potassium, but fluorine. The answer is no. Fluorine is the most active element of all the anions in the halogen series. So it's fluorine, chlorine, bromine, and then iodine. So this will not occur, and we get no reaction for this one. It is a single replacement reaction. Let's look at number 8. We have calcium hydroxide. It's by itself, so it just has to break down. And this is a tough one. It's hard for you to know without experience what it's going to break down to, but it will break down into calcium oxide and water. Calcium oxide and water. It's a decomposition reaction that is 1-1-1 balanced, right? Just takes experience to learn those types of reactions. It's really difficult to know, other than its decomposition, it's really difficult to know that it would be calcium oxide and H2O. But experience will just have to help us there. Here we have a hydrocarbon and we have oxygen. We're back to combustion here. That means we're going to have CO2 and H2O as the products. This one might be a little bit more difficult to balance, but it is 2, 15, 12, 6. Notice that we have an even number here, an odd number here, so we couldn't reduce it. It is combustion and it is balanced now. Let's look at number 10. Number 10, we've got sodium hydroxide and nitric acid, HNO3. Now, this is a double replacement reaction, but it's a little bit different than the double replacement reactions that we've looked at earlier, in that we've got sodium nitrate, which is, by the way, soluble, and then we've got water. I want you to know that if you get water as a product, we've already talked about how if you get precipitate as a product, the reaction is going to go. But if you get water as a product, it's going to go. In addition to precipitate, if you get water, it's going to go. And this one is giving us water on the right-hand side. It's a double replacement reaction that balances 1, 1, 1, and 1. Let's look at number 11. We have copper by itself and we have silver nitrate. Obviously a single replacement reaction. The only question is, will copper overtake silver? The answer is yes. Copper is higher on the activity series chart. Check that. It's higher on the activity series chart than it is silver, and so it will overtake it, and silver will be by itself. This reaction is balanced by 1, 2, 1, 2, just like that. All right, very good. Let's go to the next one. We have potassium iodide and sodium nitrate. Folks, there's just no reaction here because of the fact that no precipitate is formed. It's just that simple. It's a double replacement reaction, but if no precipitate and no water is formed, you don't have a reaction. This one is no reaction. Let's look at number 13. We've got essentially two elements together. We've got strontium and diatomic nitrogen. There's nothing to do except put them together. Strontium is +2, nitrogen is -1. When we do the switch, the 3 goes here and the 2 goes there, just like that. Okay, so that's a synthesis, and it balances 3, 1, and this should be a 1 right there. Okay, all right, let's take a look at the next one. Number 14, we have mercury oxide, and it's by itself, so the likelihood is it's just going to break apart. It's going to be a decomposition. It's going to decompose into mercury, a metal, so it's by itself, and oxygen gas, right? So we know that when we have a metal, it's by itself. When we have oxygen, is diatomic. It's a decomposition that will balance as 2, 2, 1, just like that. All right, next one. Number 15, we have C4H10, obviously a combustion because of the fact that this is a hydrocarbon. We have oxygen gas on the left-hand side as well, so our products are the same every time, CO2 and H2O. This combustion reaction is going to balance 2, 13, 8, 10, just like that. If you need work on balancing chemical reactions, go back and watch a previous video on balancing chemical reactions. All right, number 16, we've got a single replacement reaction. We've got sodium here and we've got H2O. The question is, will sodium replace hydrogen? It is in fact higher on the activity series. It will replace hydrogen. So we have NaOH and H2. It's a 2 to 1 to 2 to 1 ratio, balanced. All right, let's go to the next one, number 17. We've got lead nitrate and potassium chromate. So it's a double replacement reaction. Will it go? And the answer is yes. If we look at, for example, lead and chromate on the solubility chart, chromate will be in the insoluble category. So this one right here is going to be a solid. So I'll put a little S right there. The lead nitrate is going to be A. Let me just take a quick look. It will be soluble. Doesn't matter, however, because we have a solid right there where it's going to go. So we get a 1 to 1 to 1 to 2 ratio. This one's balanced. Let's look at number 18 now. We've got iron by itself and we've got copper to chloride. It's a single replacement reaction. Will iron overtake copper, and the answer is yes, it will. It's a single replacement reaction. Iron is higher than its copper, so it's going to replace it. We get iron chloride, right, just like that, plus copper by itself. Number 19, we've got H2 and N2. All we can do is stick them together, so when we do that, we get NH3. And remember, the N is plus 3, the H is minus 1, so we get, when we cross NH3, 3, 1, 2 will balance that reaction right there. That is a synthesis. And last, number 20, we've got sodium hydroxide and H2SO4. Folks, this is called an acid-base reaction, neutralization reaction. And we're going to combine the Na with the SO4. We get Na2SO4 because SO4 was minus 2, sodium was plus 1. When we did the switch, we got they simply cancel each other out. Excuse me, I'm sorry, they don't cancel each other out. This is plus 1, not plus 2. Okay, let me erase that. So this one is plus 1. They don't cancel each other out. The SO4 is, there's one of them. The Na, there's two of them, plus 2H2O. That's a neutralization reaction. So we have 2, 1, 1, 2, just like that. All right, hope that makes sense. If not, pause the video, ask questions, and then watch it again. I'll see you in the next one. Thanks. Bye-bye.